In college algebra, this would be a function. This could be a picture of a derivative, which is also a function. It could be a picture of the second derivative, which is also a function. So it could be any of the pictures of any of the three. What we want to know is what is its behavior at the zeros. Well, as I take a look at this, I notice this is a straight line. Now, what does a line mean? This means multiplicity 1. And I also note that on one side y is negative and he changes to y positive. Why? Because he crossed the x-axis. Multiplicity 1, negative to positive. Now here is also another multiplicity 1 because it's a line as it goes through the x-axis. So it's also multiplicity 1. And you will note here y changes from positive to negative. Now that's why, because he crossed the x-axis. Here, I notice I have a parabola, and this is multiplicity, and you could say even, because a parabola could be 2, 4, 6, 8, don't know. But what do I notice? I notice that here, y is negative, and here, y stayed negative. So it went from negative to negative. Comes out, hits the axis, comes back down, doesn't cross, just touches. And then we notice this S-curve. And the S-curve is multiplicity odd. And then we notice that y is negative, and it moved to y positive. So it changed as you went across. Now, if I took the graph away and did what we do in calculus, whether it's the derivative, first or second derivative, this is the x-axis, and I mark my critical values. There's a critical value here, critical value here. Where the parabola thingy is, there's a critical value. There's a critical value. So I put my critical numbers on the number line. I will note the multiplicity. The first critical number is multiplicity 1, so there's a change across that critical number. Second critical number is also multiplicity 1. There's a change in y as you cross that critical number. The third critical number is multiplicity even. There is no change. The fourth critical number is multiplicity odd, change. Now I pull one test point. Doesn't matter. I pull my test point here. My test point here is negative. Now, without looking at the graph, there's no change. Negative stays negative. Negative changes to positive. Negative changes to positive. Positive changes to negative. Below, above, below, below, above. Below, above, below, below, above. So now if this were the first derivative, this would say decreasing, increasing, decreasing, decreasing, increasing. This would say minimum, maximum, nothing, minimum. That's the first derivative. Second derivative, the change would give you the inflection points. So in essence, if I know what my critical numbers are and their multiplicities, I only have to pull one test point, and then the rest of it falls. And the ones in this class are not too many that's real complicated. In college algebra, as you're going to see, the next page comes from college algebra book class. The problem's a little bit more complicated because it is college algebra. I wish I would have known this when I was a student. It would have saved me a world of time.